Slot grinding is a precision metalworking technique used to create narrow grooves, channels, or slots in various materials, particularly metals, for applications ranging from keyway cutting in machinery to decorative engraving and custom fabrication. This method is especially valuable in industries like automotive, aerospace, and toolmaking, where accurate material removal is essential for fitting components or improving functionality. When performed with carbide burrs, small, high-speed rotary tools made from durable tungsten carbide, the process becomes highly efficient, allowing for controlled, aggressive cutting in tight spaces. Carbide burrs are attached to die grinders or flexible shaft tools and excel due to their hardness, often rated at 9 on the Mohs scale, heat resistance, and longevity compared to traditional grinding wheels or files. In regions like Mason, Ohio, with its proximity to manufacturing hubs in Cincinnati and Dayton, slot grinding with carbide burrs is commonly employed in local shops for tasks such as customizing engine parts or repairing industrial equipment, often influenced by the area's strong automotive and aerospace sectors. This guide provides a comprehensive step-by-step exploration of slot grinding techniques using carbide burrs, including preparation, execution, variations, best practices, safety considerations, and common pitfalls. It draws from established machining principles outlined in resources like the Machinery's Handbook, a staple reference for machinists, and guidelines from tool manufacturers such as Norton Abrasives or SGS Tool Company. While the focus is on metals, ferrous like steel and non-ferrous like aluminum, these techniques can adapt to plastics or composites with adjustments for speed and pressure. Fundamentals of carbide burrs in slot grinding. Carbide burrs come in various shapes, e.g., cylindrical, ball-nose, tree, or flame, and cut styles, single cut for coarse removal, double cut for finer finishes, making them versatile for slot grinding. Their fluted design allows for rapid chip evacuation, reducing clogging and heat buildup. For slot grinding, a cylindrical or end-cut burr is often ideal, as it provides straight, even walls in the groove. These tools operate at high PMS, typically 10,000 to 30,000, but speed must be matched to the material. Lower for softer metals to prevent melting, higher for harder ones to maintain efficiency. In Mason, Ohio, where humid weather can affect metal oxidation, using burrs with anti-corrosion coatings, available from local suppliers like Granger, helps maintain tool integrity during extended sessions. Step-by-step technique for basic slot grinding. Preparation and setup. Begin by securing the workpiece in a vise or clamp on a stable surface to minimize vibration, which can lead to inaccurate cuts or tool breakage. Mark the slot's outline using a scribe, layout die, or digital calipers for precision. Aim for tolerances as tight as 0.001 inches in professional settings. Select an appropriate carbide burr, a single cut for initial roughing on tough materials like stainless steel, or double cut for aluminum to avoid gumming. Ensure your die grinder is calibrated, with colettes tightened securely. If working in a home garage in Mason during Ohio's variable weather, consider a dehumidifier to prevent moisture-related slippage. Initial cutting and material removal. Start the tool at a moderate speed, around 15,000 RPM, and approach the marked line at a 15 to 45 degree angle to the surface. Use light, consistent pressure in a pecking motion. Short bursts of contact followed by lifts to prevent binding and allow chips to clear. For deeper slots, work in incremental passes, removing no more than 0.5 to 1 millimeter of material per layer. This layered approach maintains control and reduces heat, which is crucial for aluminum to avoid distortion. Rotate the burr slightly during cuts to distribute wear evenly and achieve uniform slot walls. Refinement and widening. Once the basic groove is established, switch to a finer burr or adjust speed upward for smoothing. Widen the slot by making parallel passes along the edges, ensuring symmetry. For curved or irregular slots, use a ball-nosed burr to follow contours smoothly. Measure progress frequently with calipers or depth gauges to stay within specifications. In applications like creating key slots and shafts, common in Ohio's machinery repair shops, blend the slot's ends gradually to avoid stress concentrations that could lead to fractures. Finishing and cleanup. Conclude with low-pressure passes at reduced speed, 10,000 RPM, to polish the slot's interior, removing any burrs or rough spots. Use compressed air or a vacuum to clear debris, then inspect with a magnifying tool for imperfections. If a high-gloss finish is needed, follow up with abrasive pads or polishing compounds. Post-grinding, apply a rust inhibitor on ferrous metals, especially in humid mason climates where condensation can accelerate corrosion. Advanced variations and specialized techniques. Blind slot grinding. For slots that don't extend through the material, e.g. in engine blocks, use a pointed tree-shaped burr to start the cut precisely, then transition to cylindrical for depth. This requires extra caution to avoid over-penetration. Employ depth stops on your grinder if available. Tapered or angled slots. Achieve tapers by tilting the tool progressively or using flame-shaped burrs. This is useful in aerospace parts, like those produced near Wright-Patterson Air Force Base in Ohio, for fitting tapered pins. High-volume production. In repetitive tasks, integrate carbide burrs with CNC rotary tools for automation, programming paths to follow slot geometries. Manually, use guides or jigs to ensure consistency across multiple pieces. Material-specific adaptations. On ferrous metals like cast iron, apply cutting fluid to cool and lubricate, preventing sparks. For non-ferrous like copper, opt for slower speeds to manage heat and chip adhesion. In hybrid materials, e.g. metal composites, alternate burr types mid-process for optimal results. Best practices and optimization tips. To maximize efficiency, always match burr size to slot dimensions. Smaller burrs, 1/8 inch diameter for narrow slots, larger 1/4 inch for wider ones. Lubrication is key. Use water-soluble oils for cooling or dry lubricants, like graphite for clean cuts. Maintain burr sharpness by cleaning flutes with a brass brush after use, and replace when flutes dull to avoid poor finishes. For extended sessions, take breaks to cool the workpiece, especially in warmer Ohio summers when ambient heat can compound thermal issues. Experiment with variable speed grinders to find the sweet spot. Too high RPM can cause vibration chatter, while too low reduces cutting efficacy. Safety considerations and common pitfalls to avoid safety is paramount. Always wear full PPE, including safety glasses, hearing protection, and a dust respirator, as carbide grinding produces fine particles that can irritate lungs, a noted concern in industrial areas like Ohio. Secure loose clothing and work in well-ventilated spaces to disperse metal dust. Common mistakes include applying excessive pressure, leading to burr breakage or workpiece gouging. Counter this with a light touch and proper tool support. Overheating is another pitfall, causing warping in thin materials. Mitigate by monitoring temperature and using intermittent cuts. Finally, neglecting to deburr slot edges can create sharp hazards, so always finish with chamfering.